In this video, I am going to show you how to turn this humble looking little PCB into the most awesome Roland MT-32 MIDI synthesizer from the 80s. I'm going to take you through step by step just how easy this thing is to build. It might look a bit intimidating, but I can assure you it is really straightforward to do. So why do you want to build one of these things then? Well, apparently they were very good for home musicians on composing music. But I know nothing about composing music. But one thing I do know quite a bit about is 80s computers. And what made these awesome is instead of having your beeps and bops like you'd get from your normal sound chip on, as we will demonstrate, the Atari ST, it turns it into a completely different experience. It's like having an orchestra accompanying you with the music and sound effects of the games. When I say this is awesome, this is 110% the best thing I have built in my little project videos today. It is amazing. Now, if you don't have an Atari ST, don't worry, because it was also compatible with the Apple Macintosh, the Commodore Amiga, and it was also compatible with a lot of early PC games as well. And I will put a list to the link of all the games it's compatible with. Now, it's not a big list, but it's a list nevertheless. A lot of the Sierra Online games were incredibly popular and supported these modules. And what we will do is I'll show you the difference, the colossal difference it makes between the onboard sound versus one of these. So before we get started with the build, let's just take a look at what this little device is emulating. The Roland MT-32, a multi-timbral sound module, was launched in 1987 by Roland Corporation. It was originally priced at $695 or £450 in the UK, which is equivalent to around $1,860 in today's money, or thereabouts £1,200. Originally marketed to amateur musicians as a budget-friendly external synthesizer, the MT-32 quickly found its niche in the emerging computer music scene. It became a favourite amongst PC gamers and hobbyists for its advanced sound capabilities. So what made the MT-32 so popular in the computer scene? Well, it's its ability to produce rich, immersive audio experiences in games like King's Quest IV and Leisure Suit Larry 3. The MT-32 soundtracks were a game changer, quite literally. So let's look at the bits and pieces you will need. I will include a link in the description so you'll get a proper list of this later. But let's just have a quick look. We've got here a Raspberry Pi 02W. Now, I do believe the project is compatible with others, but that is what I'll be using. We'll need a memory card for the Raspberry Pi. We've got an optocoupler there, which will keep the signals of the MIDI away from the Raspberry Pi. We've got a few momentary push-button switches, 4 of those. Little diode. Some PCB pins just for this little board here, which is a digital to analog converter. I've got a choice of screens there. I've got 2 screens, and I'm going to go with the 128x64 rather than the smaller 128x32. So we'll get rid of that one because that's the one we'll be using. A 1K resistor, a 220 ohm resistor, a 100 nanofarad capacitor, and the GPIO connector for the Raspberry Pi. Now, you may wonder why this board's hanging around in the background, because this very kindly donated my 220 ohm resistor, because of all the sizes, I have every size you can think of, but 220 ohms. I must have just used them all up for some reason. So thank you to that broken Spectrum for helping get this project up and working. We'll also need the MIDI cable to connect between the project and the Atari ST. We've also got a 5-pin MIDI port. And last but not least is this beautiful looking PCB, kindly supplied by the sponsor of this video, PCB Way. Whether you are starting out in soldering or a seasoned tinkerer, PCB Way have something to offer you. With literally thousands of projects to inspire you, there is sure to be something there. With PCBs starting from as little as $5, the quality, as you can see, is truly excellent. But they don't just offer PCBs, oh no. They also offer CNC machining, sheet metal fabrication, and if, like me, you don't own a 3D printer, then they also do 3D printing. So don't forget to check them out. There is a link in the description. Thank you to PCB Way for sponsoring this video. Now, you will need to download some software and install it onto the Raspberry Pi, obviously. Now, I've done a lot of this already. However, this is the link that you want to go to. You can click through on the project pages, which will be linked in the description, but this is the link that you want to go to. And the software that you're wanting is this for the Raspberry Pi. And then once you've downloaded it, you just need to extract it onto the SD card. And once you've done that, you should end up with something like this. Now, there is some additional software you'll need to download. You'll need to download the ROMs, which we've got here. And because these are subject to copyright, I'm not providing you with a link for it, but you should be able to find those with a quick search on Google. Those are the 2 ROM files that you will need. And then once you've downloaded them, just put them back into the ROMs folder and the Raspberry Pi will find them fine. The other thing that you will need to do is you will need to configure some settings for it to work properly with your particular configuration. Now, if we look at what I've done, yours might vary slightly differently depending on what screen you've gone for, but if you open it with Notepad, just scroll through and you can make the necessary edits. Now, obviously, the default synth we want to be the MT-32, and whatever the values are here, you just type in down here into. So these are all commented out, so the Raspberry Pi isn't reading these, hence the hash. So the values you want to change is where there's no hash there, and you want to copy the entry from above. So there we've got MT32 typed in. The other settings, I've not made a great deal of changes to. I've left them as default, which works fine for me. I have changed the screen refresh rate because it advises here using the larger screen, you might want to increase it to avoid flicker. So I've increased it to its suggested value there, and it works perfectly on my screen. Now let's move down a little bit further. So here I've got the output device. I'm wanting it to output onto the digital analog converter. So I've changed the value here to I2S, which if you're using the digital analog converter, you'll want to do the same. Sample rate I've left as default. Likewise, the chunk size. I'm not interested in swapping around the stereo channels. And using the 4-button scheme, which is what we're using on this build, I've just changed the scheme to simple buttons. Notice we've got the underscore. It's exactly the text that you want to put in here is exactly as it's highlighted there. So I would suggest copying and pasting just to avoid making any mistakes. We can move down. We're not using a rotary encoder. We can just leave that on its default settings. Likewise, I've not changed any of this. I've left it as it is. What else have I changed? I've left all this as standard. I've left all this as it came. Once again, I've not changed any of these default settings. And then when looking at the LCD driver, depending on what screen you use, well, depending on what settings you need to put in here, but I am using this as my screen. I've checked that and this is the correct one to use. So I've updated it and put the type in that I will be using. So you need to check which type of screen you're using and make the appropriate changes. Right. Then for the screen size, if you're using the smaller screen, your settings may be different to mine, but my screen width here is 128, and because I'm using the 64 the 64 pixel depth screen, I've changed that value to 64. If you're using the small one, then you'll have that set to 32 to correspond with your screen. And the rest of it, I think, is default. Yeah, I don't think I changed any of those other settings. None of those are relevant to me. But if they're relevant to you, then change them as you see fit. And then once that's saved, that is the Raspberry Pi configured and ready to go. That is literally all you need to do. So if you've been working on the files on the SD card, then that's everything done. So we've got the ROM files, we've got all the rest of the Raspberry Pi software, and we've configured it with our appropriate settings. Well, this is the exciting bit. It should be all ready to go. I've double and triple checked everything, so it should be good. And I've also installed some standoffs just so it's not rocking around quite so much. I was going to install some on the front as well on the Raspberry Pi, but I think these are M2 and I've only got M3, so I've got some M2 standoffs on order as well. So it's just on a bit of an angle at the moment. I've got the 3.5mm jack connected up to a little portable speaker, and I've got the MIDI cable connected to the Atari ST to the MIDI out. So it really is now. Should we do the peel? Let's do the peel. Feeling very confident. Right, let's have some power. Yes.
Big boy.
It's working, isn't it? Got the logo on. I think that is everything, isn't it? See what the buttons do. Volume down, volume up. Don't know what that is. MT-32 mode. What does that button do? All right, so you can potentially swap it between different ROMs as well then, I'm guessing, to emulate other synthesizers. I think I read that somewhere in the blurb. So that all seems to be working perfectly. Right, let's fire up Space Quest 3 and give this a try, see if it really is working. Before I demonstrate the MT-32, I think it makes more sense to show you what the sound is like on the Atari ST itself using the onboard sound. And I'm going to do that with an emulator just because I don't have a capture card, and just to give you a better experience really watching the video. So the Atari ST sound that you're going to hear is going to be from the emulator, but it matches pretty much like for like what the ST produces. The only difference is I'm not going to be using a crappy mic to try and capture that audio. And when it comes to using the MT-32, I will be using the line out from the M32 straight into the PC. So the video that you'll be seeing will be emulated, but the audio itself will be coming from the MT-32, just so that you know what it is that you're watching and listening to. Another thing to note as well, when you do come to running the software, you do need to tell the machine what hardware it is that you want to use. And this is on the Atari ST, and I'm guessing it's going to be a similar process for the Amiga or the Macintosh or whatever it is that you're using. But as we can see with Space Quest here, we have a little file called music program, which we're going to run. And what we're going to do is we're going to tell it to use the Roland MT-32, which will OK that. And then we'll click on install game, which will save it. Then when we come to run Space Quest 3, it will use the MT-32 rather than the onboard sound. I'm sure you'll agree the difference between the two is like night and day. I don't really need to say any more than that. And when you start playing some of these games and you stick a pair of headphones on, the experience is just amazing. I never played these games first time round, and now I'm absolutely obsessed with them. So hopefully this video has inspired you to have a go yourself, and hopefully I've made it nice and simple for you to follow along. If there's anything I've missed, drop me a comment. I will read every comment as always, and I will respond to you. Don't forget to subscribe if you like the stuff that I do, and there is a link in the channel description if you'd like to support me and become a member. As always, thank you for watching, and hopefully see you again soon. Bye for now.